Okay, so all right. So you see, so today we're going to, for example, first of all, we will continue on the topic of constant acceleration. Okay, so and then if time allows, we'll go to another chapter which is about vectors. Okay, so so let's recall a few equations which basically relates several quantities like the displacement, for example, the initial velocity, final velocity, and then the acceleration, and then the time. Okay, so these 5 things. All right, so so in total 5 equations. Okay, so let's look at the first question here. Okay, so so we see so we have a particle moves on a straight line, and then from a point A to point B with constant deceleration 1.5 meter per second. Okay, and then the velocity of the particle at A is 8 meter per second, and then the velocity of the particle at B is 2 meter per second. Okay, and then part A, find the time taken for the particle to move from A to B. All right, so first of all, we have a new term here, which is called deceleration, right? So basically deceleration means negative acceleration. Okay, can you understand this? Sorry, I can't hear you. All right, yeah. So that means, for example, your particle. So that's why you'll see that the velocity initially is 8, and then the final is 2. Okay. All right. Then for part A, we want to find the time. Okay. So this is, so basically we have u equal to 8 meter per second, right? U equal to 8 meter per second. And then v here is 2. Oops, sorry. By the way, I can't use the pen to draw and draw something on the Word document, because I think there's some problem in my computer. Okay. By the way, okay. Anyway, back to here. So oops, sorry. So we have v equal to 2 meter per second. Okay, and then the time taken we use, and then the a here is I think a is negative 1.5 meter per second square. Okay, so which equation should we use? Okay, so we want time. So let's see. So this, I think the first equation will be suitable, right? Because we have v, we have u, we have a, and then we're looking for time. Okay, so now let's apply the first equation. So if we use the first equation, that will give us v equal to u plus at, and then v is 2, and then the u is 8, and then a is negative 1.5, and then t. Okay, then we can solve for the t here. T here would be negative 6 over negative 1.5, which is 4 seconds. Okay, so are you okay with the first
Yeah.
part A? Okay.
Yeah.
All right, part B. The distance of A. Oops, sorry. Wait a second. Let me fix it. Okay. All right. So the distance from A to B. Okay. So So that means it's equivalent to the displacement. So which equation should we use? Okay, so now we have u, we have v with a, and we want s. So I think which equation can we use? I think this equation we can use, right? Because this equation don't have time. Actually, you can use the other because you have time, right? But then maybe this answer may be incorrect. If you make mistake in this question and then use this result, that will cause you trouble, right? Because so it is smart not to use the result in A to prevent all these mistakes. Okay, anyway, so back to here, we should use the third equation. So v squared equals to u squared plus 2as. Okay, and then v here is 2, and then u here is 8, and then plus 2 times a is negative 1.5, and the s is the unknown, and then we can solve for the s here. So the s here, this one is 2 squared minus 8 squared, 19. Okay, maybe I use calculator to find it out. 20. I think I have 20, right? Okay, so that's the displacement, and that's the distance between from A to B. Okay. All right, C. So after reaching B, the particle continues to move along the straight line with a constant deceleration of 1.5 meter per second square, and then the particle is at point C 6 seconds after passing through the point A. Okay. So now let's maybe draw a picture to visualize the situation. So we have 3 points. So remember we have point A, which is here. We have point A here. Okay. Let me fix this first. Okay. So and then we have a point B at the middle. And then we have another point C. Okay. So we have 3 points here, and then the situation is like we have so the last sentence here means it takes 6 seconds for the particle to go from A to C in total. Okay. And then well this one then you will find that the result in A is useful, right? Because once you have the time from A to B, then because this time is from A to C, then you'll be able to find the time from B to C, right? So so from B to C, okay, from B to C, the time is 6 minus 4, which is 2 seconds. Okay, so you got to draw a picture because sometimes a little confusing about these complicated situations. Okay, and then we have the time. What else do we have? Okay, so actually we have the initial velocity at B as well, right? Because well the mention here is you see the velocity at B is 2. So at B, that's the initial velocity. Okay, so U is 2 meters per second. What else do we have? Okay, we also have the deceleration again, right? Because the deceleration here is 1.5 meter per second square. So that means the A here, remember to take a negative sign here. So negative 1.5 meter per second square. All right. So once we have 3 quantities, we are safe to find other quantities. Like example, we want the velocity of the particle at C. So well, if we are at C, then that means that's the V, right? That's the V here. So we want the V. So now we have T, U, and A. Which equation should we use? T, U, and A. So I think the first equation will be used because you have U, you have A, you have T. So V here, so V equals to U plus AT. And then you plug in the quantities. V is unknown, and then U is 2, and then A is negative 1.5, T is 2. So that means 2, this one is negative 1 meter per, negative 1 meter per second. Okay?
Yeah.
All right. And then D, let's see. Sorry. All right, and then D, we want the distance of A from C. Okay, so physically it makes no difference to find distance between A and distance from A and C and displacement from A to C. Okay, unless they're asking about the distance traveled by the particle. Okay, that's different. Okay, here we're talking about distance from A to C. So we want to find displacement. Okay, so again, which equation should we use? So we have U, A, and T. So maybe this equation is useful. Okay, this equation is useful. So we have yes, S equal to UT plus half AT squared. And then next we want to find consider the quantities. By the way, this is starting from A. Okay, this is considering the situation where it's starting from A. So and note that we can consider the whole journey at once because the deceleration is constant. Okay, it's all 1.5 meter per second squared. Now, if we have another question, for example, which you have this is 1.5 and this is 2.5. Okay, then that way you need to consider a journey into, you need to cut the journey into 2 parts. Okay, because the deceleration is different. You can't use the constant acceleration equation. Is that okay for you?
Yeah.
Okay, so this one we can consider just the whole journey at once because it has a constant acceleration all the time. All right, and then now U is different from the U in A, in C, by the way, because this U is referring to the speed in B. So you need to be clear in mind what you're talking about. For example, what is initial to you? Okay, so for example, this one, the initial speed is talking about the speed at A. So U is 8 instead of 2. Okay, and then the total time is 6. So 6 here, and then plus a half. Acceleration is always negative 1.5, and then the t here is again 6 squared. Okay, so in total, what's this? 8 times 6 minus a half, 21. Okay, we have 21 meter here. Okay, so that's the distance of A to Z. Is that okay for you?
Yeah.
All right. So all right, next question here. So we have a car which moves from the traffic light to along a straight road with constant acceleration. The car stops from rest at the traffic lights, and 30 seconds later, the car passes a speed trap where it is registered as traveling at 4 km per hour. Okay, And then we want to find the acceleration and displacement between the traffic light and the speed trap. Okay, so first of all, we have to be careful about there's some keywords, because a lot of times people keep forgetting about that. Okay, now the first term we need to know is this one we have no ambiguity. But then, for example, what does it mean by starting from rest? Okay, so that means, so starting from rest basically means that the speed is 0 at t equal to 0. That's the meaning. Okay, and then once we have this, then and then let's find the variables or the parameters. Okay, so for example, the time here, our time here is obviously 30 seconds. That one should be okay. And then also we have the speed, which is 45 km per hour. Okay, so as I mentioned, we have something called SI units, which means there are some standard units that you should use when applying the equations. Okay, so here for distance we tend to use meter, and then for time we tend to use seconds. So we basically want this speed to be in meter per second. So our problem here is how do we convert km per hour to meter per second? Okay. So the skill is easy. Basically, you got k here. K, you know k, right? K means 1,000, and then basically 1 hour is 60 minutes, and then 60 minutes, 1 minute is 60 seconds. So there are in total 3,600 seconds in an hour. So that's the conversion. Okay, so meter per second. Is that okay?
Yeah.
And 1,000 over 3,060. That's 1 over. That's 3.6. Okay, so this one we have this. So because that's 1 km per hour equal to 1 over 3.6 meter per second. So we can convert it into, so we can convert 45 km per hour into meter per second. So we multiply 45 to both sides. That's 45 km per hour equals to 4.5 and 45 over 3.6 meter per second. So that's 45 over 3.6, which is 12.5 meter per second. So that's the speed in SI unit. And then once we have this, that's exactly U. So U is 12.5 meter per second. Okay. And then how about sorry, no, this is not U. This is V. Okay. What is U then? U, because 0, right? Because it's initially at rest. So so U equal to 0. Okay. So again we have 3 quantities, namely U, V, and T. So again we need to choose the correct equation to find the A. Now I think the first equation should be the correct one, right? Because we have U, we have V, we also have T. So we can find A here. Okay, so V equal to U plus AT. And then so once we have this, we this is 12.5 equals to 0 plus A. A is the acceleration, and then T is the time, which is 30 seconds. So so A here would be 12.5 over 30. So it's around 5 over 12, or if we take 3 significant figure, that's 0.417 meter second square per second square. Okay.
Yeah.
All right, and then this is A. B. we want to find the distance between the traffic light and the speed trap. Okay. So well, without the acceleration, can we do that? Yes, of course, because we have u, we have v, we have t, so we can apply the second equation. Okay. Remember, I think I've told you last time that this is the only equation that with no acceleration. Okay. Okay, so this one we use the second equation. So we have u plus v over 2 times t, and then let's plug in the quantities. So s is what we want, and then what are u and v? So u is 0, and then v is 12.5 divided by 2 times the time times 30 seconds. So this one is 12.5 times 30 over 2, which is 187.5 meter. Okay.
Yeah.
Okay, so that's the second question. Next one. So this one, we have a particle moving along a straight line from A to B with a constant acceleration 5 meters per second square. And then the velocity of A is at A is 3 meters per second and in the direction AB. So that means the particle is going from A to B. Okay. All right. And then the velocity of the particle at B is 18 meters per second in the same direction. Find the distance between distance from A to B. Okay. So so a particle at A is this one.
Can I try this myself?
Oh, sure. Just tell me when you finish. Okay.
Okay. $31.5 meters.
31.5. Okay. Yes, 31.5. So basically the idea is use this third equation here, right?
Yeah.
We use this one. Yeah. Okay. So maybe I'll let me just leave the another two question as your homework. How about that? Okay. You tried the another two question at home.
Yeah.
Okay. All right. All right, and then next, we're going to introduce gravity. Okay. Now, because so far our particle is constrained on the real line, right? The real number line, and then actually that one is not quite realistic, right? But actually, our theory can be applied to the situation when a particle is in a is falling under gravity. Okay. But that will involve some more knowledge about gravity. So here I will introduce that. So the idea is like this. Okay, so So let's say you have a particle here. Okay, this is our particle. And then now, if the situation is if a particle is under gravity, okay, then if it's under gravity, then this particle would experience a force, right? Now, so far maybe we are a little bit ambiguous about what force means, but intuitively that would be true, right? A particle will experience a force, okay? And then now subjected to that force, then the particle would experience an acceleration, right? It accelerates towards the center of the Earth, right? So we have an acceleration here. Okay, so let me call this. Copy this. Let me just call this acceleration g. Okay. So this acceleration g, we call it the acceleration due to gravity. And g, this small g here is a very usual notation. Okay. So every time when people talk about g, basically you assume that means the acceleration under gravity. Would that be okay?
Yeah.
Okay, so that's just something new to us. And then here, that's the g here, that we have a quantity which was calculated by the physicist. Okay, so this one, the acceleration due to gravity is approximate. Now this is approximate value only, but in GC we stick to this approximate value. So the acceleration due to gravity is approximately at 9.8 meter per second squared. Okay. And also in G3, we assume that the acceleration quantity points towards the ground. That means it points downward. Okay. Now that's a very important concept here. Always point downward. It doesn't matter whether the particle is going up or going down. Okay. Now even your particle is going up, the acceleration is still going down. That's the point. Okay. Even when the particle is going up.
So when the particle is going up, then g would be negative, right?
It depends on which direction you choose to be positive. Okay, so if you choose the direction of positivity upward, then your acceleration to the ground is always negative. Okay, or if you choose the downward direction as the positive direction, then your acceleration to the gravity is always positive. That's the point. So it never changes sign. That's the point. Okay. Would that be okay?
Yeah.
Okay. Because why I emphasize this one is because a lot of people, they tend to have a misconception about the motion. Some people may think that if the particle is going up, then the acceleration is going up. No. From the first lesson, I told you that, right? I told you that the direction of the velocity has nothing to do with the direction of the acceleration. Okay, that's the concept we need to know. All right. So that's the acceleration due to gravity. And then the rest will be just the same. Okay, so basically we have one extra information, which is if the particle is in free fall or it falls in gravity, then the A is 9.8. or negative 0.8, depends on the direction you choose to be positive. Okay. Because we okay, so let's look at some example. So so for example, we have a book which falls off from the top shelf of a bookcase. Now that means it is hidden that it is falling under gravity, right? And then another shelf is 1.4 meter above the wooden floor, and then the question asks to find the time the book takes to reach the floor, and then the speed with which the book strikes the floor. Okay, so first of all, let's draw the picture. So actually, the main point is that the book falls, right? It falls from a first certain distance from the ground, which is 1.4 meter, I suppose. So we have, this is 1.4. Now, because the book falls off from the shelf, that means its initial velocity should be what? What do you think?
0.
0, yes. So u is 0. And how about the a? Okay. So maybe let's, from now on, we build a habit to choose a direction which is positive. Okay. Because in this situation, we do not have really a definite coordinate system. Okay. So we choose maybe downward as positive.
But
In that
really
case, it really matters, because, for example, if some quantity is going up, then you need to choose the negative sign. And for example, if your result is show up to be negative, that would means that your quantity is actually going up.
Okay, but in this case, there's only one. It's one way, so it doesn't matter, right?
I would say yes. Okay, but in some case that would require some more careful treatment. So this is the habit you need to build up. Okay. All right, then where's A? Okay, so A here should be, I think, 9.5, as I mentioned, meter per second square. And then how about what else do we have? We also have the displacement, right? So S is 1.4. Now, because it's going downward, because it's going downward, now the displacement is pointing downward actually here. So it's positive here. Now if we set upward as positive, that would be troublesome, because the book is going downward, so the displacement should be negative. Okay. Is that okay?
Yeah.
Okay. So you need to be careful. And then next, part A, we want to find the time the book takes to reach the floor. So as the book reached the floor, that means which equation should we use? Okay, so we have U at A and S, and then U, A, and S, we should use, I think, this one, right? Okay, so S equal to UT plus a half AT squared. So S is 1.4, U is 0, and then a half times 9.8 T squared. So we can solve for the T. T is 1.4 times 2 over 9.8, and then we take the square root, so 0.536 seconds. Okay?
Yeah.
Okay, so that's part A. All right, and then part B. Part B, we want to find the speed with which the book strikes the floor. Okay, So we want to find v, okay? So which equation should we use? I think we should use this one, right? So v squared equals to u squared plus 2as, and then oops. And then v squared is u is 0, and then 2a s is 1.4. So you can find the v here. Two times 9.8 times 1.4, so it's 27.44 meter per second. Okay.
Yeah, I just remembered something. I know my exam board now.
Sorry, can you repeat?
I know my exam board now.
I know. What do you mean? What do you mean? Sorry.
Like exam board.
Oh, you know. Oh, you know exam board.
Yeah.
What is exam board?
It's OCR.
OCR. I see.
And for the math, it's Edexcel.
Further math at Excel.
Yeah.
Okay, so you have different.
Yeah.
So OCR is for math.
Yeah.
And then further math is at Excel.
Yeah.
I see. Okay, and then anything you want to add?
No.
No. Okay. So
Yeah. You said V is 27.44.
uh-huh.
Don't you mean V squared?
I think I forgot to take a square root, right?
Yeah.
So 5.24. Okay. All right. So that's part B. All right, and then next one. So
Oh, can I try it?
okay. Now here, let me give you some hint. So now let's think about when will the particle reach the highest height? Okay. Oops, sorry. So the particle will reach its highest height when the velocity is 0. Can you think of can you get why?
Yeah.
Why?
It's the turning point.
It's a turning point.
Because like
Yeah.
when you lose velocity, it just starts dropping.
Yeah, I would say because if the velocity is non-zero, it's either going up or going down, right?
Yeah.
At the next instant. So if it's going up, then it won't be the highest height, greatest height. It's going down, then certainly that position is not the greatest height as well, right?
Also,
Okay, yeah.
Does S equals displacement or distance?
Displacement.
Okay.
And in certain instance, displacement is just the same as distance.
Yeah.
In the sense, for example, for the last question we have, for example, the displacement, we talk about the distance between 2 points. That's the same as the displacement. Okay. But when you talk about the trajectory of the particle, the particle may go back and then go back and go front, right? Then in that case, distance is not the same as displacement. Okay. So here so for A, wait. Okay, so for A, the hint is B equal to 0. And then for time of flight, for time of flight, that is when s is 0. Do you get why if s is 0 for part B?
No.
No. No, because what does it mean by s equal to 0? That means it returns its original position, right?
Yeah.
So that's the you think about the
it should be -7. I thought it should be -7 because it's gonna hit the ground, right?
Well, if you talk about -7, you're talking about the time for the ball to fall from the highest point to the ground, right? But here I'm talking about the time of flight, which means it's talking about the time where you project the ball upward and then it goes down. That's the whole journey.
Yeah. But doesn't the ball end up on the ground?
Yes, it ends up on the ground. If you talk about -7, you're talking about you start from the highest point. That's not correct, right? You start from the ground and then you end from the ground.
No, but
End on the ground. Yeah.
but it starts at 7.
Oh, wait. Oh, sorry. Yeah. Oh, then it's -7. Then. Yeah. Sorry. It depends. Which direction have you picked to be positive? If you pick downward to be positive, then this should be 7, right?
No, I picked upwards to be positive.
Yeah. If you take upward to positive, then you're correct.
Okay.
Yeah. Sorry. I didn't look at the question very carefully. Yeah. If you start from the ground and end at the ground, then certainly s is 0. Yeah. Okay. Do you get the answer here?
No, I'm still thinking.
Oh, you're still okay. Okay. So
I'm not sure which equation to use.
okay. So now first of all, you have for part A, what do you have? You have u if up is positive, let's say. Okay, so upward is positive. Then for the first case, we have v equal to 0, and then u equal to 21. And then
Yeah.
maybe you forgot that a is -9.8, right? You still have a. So which equation should you use? This is the greatest height, right? So that means the displacement. Yeah.
Third one?
That one.
Okay.
Yeah. Oh, yeah. You use the third one to solve for the s, right? So 0 square equals 21 square plus 2.
Okay, yeah, I got it.
Yeah. And then you realize that if you choose the wrong sign for a, then you get the wrong answer for s, right? You get s to be negative. Okay, and then
so do I have to change my direction now because I got it wrong?
no, it's correct now, right? S is positive now, right?
Oh yeah. Okay, yeah.
What I mentioned is if your A is wrong, if you, for example, you write A to 9.5, then you are wrong. Okay.
Yeah. Okay.
And then how about B? Time of flight.
For B,
Hmm.
I only have U and S.
You only have U and S. No, you have A as well.
But what is A?
A is negative 9.8.
But it goes up and then goes down.
It goes up and then goes down. It doesn't matter. As I mentioned, if you fall under gravity, then the acceleration is always 9.8.
Yeah, but the sign.
Sine is negative 9.8 then. Yeah.
Okay. Like as long as, but if I don't know which one, I just look at the answer and right. Like as long as t is above 0, then I know I have the right sign, right?
Not really. Sometimes you get positive t, but still you have the wrong answer. So you need to be careful. So basically, you just have to think carefully about the direction of the quantities here. For example, s is negative 7 because it's going down, right? Finally, is if it reaches the ground, then it's below the position is below the original position, so it's negative 7. And then for U, because it's projected upward, it's positive. And then A is always pointing downward. And then you choose upwards as positive, so it's negative.
Okay.
You don't look at the answer. Sometimes the answer may be wrong as well. Even you get the opposite correct sign. Okay. So which equation would you? Okay, yeah, you use this one, right?
Yeah.
And then you get a quadratic equation.
Yeah.
Yeah. So negative 7 equals to 21t plus a half negative 9.8 t squared. Then you get the t, right? What do you get for t?
I don't have an answer.
No, I get one is negative at 0.31. One is 4.60. So 4.60 seconds is the correct answer. Okay.
Yeah.
Okay. All right, and then again we have another problem, which is
Wait,
about.
what if both answers from the quadratic are like reasonable answers?
You mean all two are positive, right?
Yeah.
I would say it depends. Okay, it depends on the situation. For example, yeah, then you have to think about what's the meaning of the two solutions. Okay.
What if they're like really close? Like for example,
It's not about whether they're close or not. No, maybe let's think about a situation in which there may be possibly two answers. For example, so let's say you have a particle, and then you project it outward, just what we did just now. And then maybe the question is asking the time. For example, maybe maybe the time for the particle to reach maybe this. Just now we have this one. What's the greatest height? 21 squared divided by 2 of 9.8. That's 22.5. Maybe the time for the particle to reach 10 meters above the ground. Okay. Well, for this situation, it's reasonable to get two answers, right?
Yeah, but in this situation, you know it's the first one.
You know, yeah, you know you success first. So it depends on situation, right? You need, so for example, you have a situation, you have a physical situation, and then you have two times, okay? And then, for example, in this situation, you know it's the time for it to reach the 10 meters above the ground first, for example. Then you know the answer should be the smaller one. Okay. Now I can't really tell you very generally because it really depends on the situation. It depends on how you understand the model.
Okay. Yeah, but what if we go back to just like the last question?
Okay. But for the last question, it's impossible to get two answers, right? Because but physically, it cannot reach the ground twice, right? So you should expect that you won't have two physically possible answers. And that's why one answer is negative, one answer is positive.
Okay.
It's restricted by the math and also restricted by the physics as well.
Okay.
Okay. So sometimes it's yeah.
So it's for this type of question, there will always be one positive, one negative.
I would say, for example, if you talk about the time for it to reach the ground, maybe there's some situation in which the particle reach the, for example, you start from the ground and then end from the ground, then there will be one answer in which one is a positive answer and one is a zero. Okay. Can you figure out why? You start from the ground and then end at the ground.
Yeah.
There should be one answer. One is zero. One is the positive answer.
Yeah.
And then if the initial point and the final point are different, maybe if it is below, if the end point is below the initial point, there should be one answer. One is positive and one is negative. And then if the final point is above the initial point, there will be two positive answers. But then the first one is not possible because it is reached first, right? And then it reached it reaches second time. Okay. Yeah. So this depends on how you understand the model. Yeah.
Okay.
It's different. So with mechanics, it's different from pure math. For mechanics, you also need to understand what is happening behind the motion. Okay. Yeah. All right. And then we have another example. Maybe maybe for these two questions, I'll let you do it at home. How about that? Okay.
Yeah.
Okay. Maybe how about maybe to increase the effectiveness, maybe you can send me, for example, I think I sent you the notes on Gmail, right? So maybe after you finish this exercise, maybe you send me the hand script so that I can maybe make some correction for you. Or if you don't know, I will just tell you that. I'll just talk about that next lesson. How about that? Yeah.
I think it's really slow when it goes through Gmail, and it's not really effective because I don't really check my emails. Could you just maybe take a picture of the question and then WhatsApp it to me?
So you want me to, so you send through WhatsApp, right?
Yeah.
So maybe I think we have in Kenya we have Gmail. I think we have WhatsApp as well, right? So maybe you send it through that WhatsApp.
Okay.
Yeah. Do you know we have WhatsApp as well?
I don't have the number.
You don't have the number. maybe you check out the Kena website. Yeah, as I currently don't have the number. Maybe check that out. Or if you don't really you can't really find that out, then you just call the Kena CS for that. Okay.
Okay. Yeah.
Yeah. So maybe. Okay. So any more questions about this chapter? Okay. Yeah. So up to here we finished the first chapter. I think we finished the second chapter of the book. I think it's the Pearson's book. Okay. And then next time we will go to chapter 3, reasonable vectors. Okay. All right. So okay. So if there's no question, maybe let's end the lesson here. Okay.
Okay.
Yeah. So okay. So that's it for today. Okay. Bye.
Thank you. Bye.